Welcome to one of the most important lessons that you're going to have this semester. We are going to introduce you to the unit circle over the next day or so. We're going to kind of give you the basics today, and so pay attention, take notes. What you're going to see is relevant information that allows us to figure out how to construct this circle whenever we want. I'm going to give you tips, not necessarily how to memorize, but how to learn how to make it. So when you're focused on what's happening around that circle, notice patterns, notice ways that you can learn things quickly in relation to what you already know. Like you already know how to count. When we have patterns, we can apply those patterns over and over and over again, so we don't have to necessarily memorize everything, but it is more along the lines of I'm learning a particular pattern that helps me to fill in the whole circle. So good luck, pay attention. If you need to watch this again and again, definitely take the time to do that. If I could give you one tip to really focus on, is to learn that left hand rule. If you can learn how to do your left hand and figure out what that means and how to get the coordinates for the unit circle, which they're not even on the screen right now, right? We've got to figure those out, but that's going to make that job super simple. So I know some people tend to forget about that or really not want to learn it. It is one of the best things that I've ever seen that helps you to learn something fairly complicated, but in a really quick way. So good luck, and we'll get started. You are looking at the unit circle. The unit circle has a lot of different components, and we don't really have all of them here at the moment, but what I want to focus in on some easy things. I'm going to give you some of the overview, and as we look at the unit circle, you can kind of identify those common patterns that we can kind of all focus on. So let's zoom in on it real quick. So what we see here is we have the unit circle, right? Let's kind of focus on what we're very familiar with so far, and that's degree measures. You can see on the outside here, we're going to start at the positive x-axis, and we're going to work our way all the way around this back to here, which we know is a full circle or 360 degrees. If you see outside the circle, you have at each of the little angle measurement points, you see the degree measures. Real quick, the pattern is it goes up 30, 15, 15, 30, and then it repeats it, 30, 15, 15, 30. 30, 15, 15, 30, 30, 15, 15, 30, right? So already, if you know where to start, which is on the positive x-axis right here at 0, everyone, can give me all the angles if you remember 30, 15, 15, 30, and just repeat it until you get to 360. You'll have all the angles done, all right? So 1 of 3, check. Already got it memorized, okay? Or maybe not memorized. And I'm going to say that over and over again. Memorization here is not the strongest tool. I think learning how to create it and using patterns allows me to save myself lots of effort and still achieve maximum results in a shorter time. So here, this part's going to get a little bit tricky. Getting the radian measures, not so much, okay, right? It's not a nice little pattern. It's fractions, so there's lots of things here that we probably don't like. Now you can kind of see some patterns going along. You can see that it's got thirds and fourths and sixths and halves, and you're going to see that kind of repeat itself, right? This would be actually 2 halves, by the way, or whole values. And here you've got sixes, fours, thirds, halves, thirds, fours, sixes. If you kind of just follow that along, you can see the sixes stay together, the 6 pi sixths, and then pi fourths are here, and then pi thirds, and it continues that pattern all the way across. That's a good way, as you're building this, you can kind of use that method to check to see if you messed up. A lot of students will flip-flop the thirds and the sixes in 1 or 2 quadrants, but they'll get them right in other quadrants, so be careful. Remember, it doesn't repeat 6, 4, 3, 6, 4, 3. It doesn't do that. Here's 6, 4, 3, but the next one you get to, it's 3, 4, 6. So it goes forwards and then backwards. I want to try and give you a different way to learn this. One of the ways that I learned it was to count to 12. I think we can all count to 12. We're going to kind of focus on some of the easier ones first. I can tell you that when I'm looking at the pi over 4s, I know this, and I keep this in my head. Pi over 4 is 45 degrees. Pi over 3 is 60, and then pi over 6 is 30. This is something that I do take time to memorize. Now, I can always calculate this by substituting the 180 in for my pi right here and dividing. That would always get me these numbers, but it's quick enough that I can just memorize those. So pi over 4, so here's 1/4 pi, 3/4 pi, 5/4, and 7/4. And this is the middle value, the middle line that runs through each quadrant, right? Halfway is 45 degrees. Halfway here is 135. And you get the ideas. If you kind of just notice the pattern, 1, 3, 5, and 7. It's odd values. So 1, 3, 5, 7 would get me instantly all 4 of my 45-degree angles. Other patterns, 45, 35, 225, 315. The 4 angles that do not end in 0 end in 5. Every other angle on this unit circle all end in 0, right? You can see that as we go around. So if it has a pi over 4 involved, you know it's one of the 45-degree reference angles. First quadrant, right? 1, then 3, then 5, then 7. So that's the first step I take. I locate all the 45-degree angles, and we're done with that part. The next part, I'm going to take it and I'm going to start talking about pi over 6s. Here's where I was referring to counting to 12, right? So we're going to find a few things. We're going to find pi over 6, pi over 3, pi over 2. Essentially every other value that we haven't talked about, we're gonna calculate that. Now some of these we kind of could probably guess at. 2 pi, 0, pi, 90 degrees is pi over 2. All of those we probably knew, but let's see how we can write this. So I'm going to write just kind of inside the pi over 6. This is going to be just 1 pi over 6. And they're going to here, this is going to be 2 pi over 6, and then 3 pi over 6, 4 pi over 6. This is obviously 5 pi over 6. This will be 6 pi over 6, 7 pi over 6. This one's going to be 8 pi over 6, 9 pi over 6, 10 pi. Ooh, that one's not good. 10 pi over 6, 11 pi over 6, and 12 pi over 6. So really, it was just a pi over 6 attached to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay? Right. So real quick, let me do it one more time. So I found the 45s first, and I put those in place. 1, 3, 5, 7 pi over 4s. It's odd number values. Then I'm going to start here. Now 0, I'm going to assume that we all kind of get 0. Doesn't matter if I'm talking about radians or degrees or anything. 0 is just 0. So I'm kind of leaving that part out. I'm going to assume you got that part down. So here we're going to say 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, you know some of these reduce. And you know some of these already, like 90 and 180, and some of them were already 6s, right? So those are your key benchmark kind of, as I'm going around, making sure I'm doing it right. If I get to a point like, oh, that should have been 5 pi over 6, but it wasn't, you know you messed up somewhere, skipped a line, went too far, too fast, whatever, okay? But if we were to simplify all of these values, we know that that becomes pi over 3. This becomes pi over 2. This becomes 2 pi over 3. So I'm really just, at this point, I wouldn't write down these as I'm writing them. It's easy enough that we can simplify those kind of as we go along. So if they simplify, which is everything but the 6s, right? The pi over 6s. I'm going to reduce those as we move along. Okay, so keep that in mind. Okay, we just did two things. We just learned the angles, the degrees, by going by 30, 15, 15, 30. And we learned how to write the radian measures using two steps. 45's first, 1, 3, 5, 7. Then we learned how to do the rest of the angles in radians using pi over 6. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then reduce them to their correct pieces, right, to their lowest terms. And that's that. That's the angles all the way around the unit circle. We're going to take a little bit longer to learn the coordinates that go along with these. So for now, let's kind of keep those things down and we'll get to the coordinates soon enough. We're going to talk about some of the pieces here. We've talked about the angles and degrees, the angles and radians. The coordinates for each angle consist of square root of 2 of fingers over 2 and the square root of fingers over 2. And you're thinking, what in the world do you mean fingers? And we'll get to that in just a minute. Using the left-hand rule, and I'm going to show you what the left-hand rule is in just a minute. Exactly how can we figure out what the left hand is supposed to do when we're giving or looking for our coordinates? Okay, so the left-hand rule works like this. I'm going to try and keep it straight. I'm actually teaching it to you backwards, but the camera is also backwards, so I think it's going to translate well. Here's your left hand, right? So hold your left hand up. You're looking at the back of your hand, and so you're going to be kind of looking at it from the back perspective. So if I kind of align my left hand, it looks a whole lot like down here. If you look at the unit circle, this is 0, 30, then 45, then 60, and then 90, right? So it's got those 5 marks there. And so the way that your coordinates work, if you look down over here where you have the square root of fingers over 2, what I need to know is those 2 fingers. What do you mean fingers? And so I'm going to put a finger down to represent the angle measure I want to find, right? And so let's do 30 degrees, right? 0 is here, this is 30, so I'm going to put this finger down. And it separates it into the left and right pieces. And so I need 2 sets of fingers, right? The left and the right. It's still in order, so X and Y, just alphabetical, however you want to talk about it. These are the numbers that go into the square root. So this is square root of 3, and then the square root of 1, but we know that one, that's just 1, so square root of 1 is going to be equal to 1. So the coordinates for this would be the square root of 3 over 2 and 1/2. Right? Let's try again for 45, 45. Here you have, I'll put down the middle finger, sorry, 0, that's 30, that's 45. Here would be square root of 2 over 2 and the square root of 2 over 2. If I do the 60, it's the square root of 1 over 2, or just 1/2. And then here would be the square root of 3 over 2. And that would get me the 60-degree angle. Let's try 90. Right? What's on the left side here? Well, that's 0, right? What's the square root of 1, 2, 3, 4? So square root of 4 over 2, that's 2 over 2. So that was just 1. So 0, 1. What's the coordinate for 90 degrees? If I go up 1 unit, it's 0, 1. Let's try 0. This would be the square root of 4 over 2, which is, remember, that's 1. And then comma, and then nothing, so 0. So is it 1, 0? Is that the coordinate for 0 degrees right here? And it is. We go over 1, that's x of 1, y of 0. Same thing with 90, we did it earlier. That was this one. That was the 0, 1. It works. So each of these coordinates are focused on which finger do we put down in terms of creating that left and right pieces, right? So when you move around the unit circle, it gets a little bit trickier, but what you're going to want to focus on is which reference angle am I working with? Am I working with a 35? Am I working with a 45? A 30, 45, or 60-degree reference angle? What you'll notice is that every angle on the unit circle is either on an axis, right? 0, 180, or 0, 90, 180, 270, or 360, or they're going to fit within that 30, 45, or 60-degree angle, and these are going to give you the numbers to put underneath those radical signs, and then you can reduce it from there.